Thank you for joining for this episode of the TechSpective Podcast. I have with me two gentlemen from Adobe, Hayden and Jericho. Jericho, if you want to go ahead and start off with a little bit of background on yourself and your role.
Sure. Yep. I'm a data scientist at Adobe in cybersecurity with the Caspian ML team. My background's in physics, where I've previously worked in atmospheric acoustics and gravitational wave astronomy. But I've been in the machine learning space for about 10 years. I've worked on topics ranging from sport analytics to healthcare and now cybersecurity.
Nice.
Yeah, and my name is Hayden Beadles. I'm a senior security machine learning engineer working with Jericho in cybersecurity. I've been at Adobe for 5 years, since 2019. Before that, worked in software engineering, data engineering. Currently getting my master's in machine learning analytics. So, excited to be here and to talk about anomaly detection.
Okay, which is a great topic, and it is why we're here. But now that Jericho did his intro, I kind of want to do a whole separate podcast just on all of the physics stuff.
Well, yeah, I'll have to remember it. It's been a while.
Yeah, I just finished. I'd seen the movie many years ago. I just finished listening to the audiobook of The Martian, and there's a lot of somewhat physics in there, but I think that the thing that I like about Andy Weir's books is the amount of like math and the detail of the research that he did to even figure out how that stuff works is impressive to me.
Yeah, I actually read that book too. It was very good.
I keep forgetting the name of his most recent one, but it's excellent. I highly recommend it. Artemis was good too, but his most recent one is Operation something something, or I don't know. I forget the title of it, but it's a very good book. Anyway, speaking of titles, let's talk about Project Caspian, because I was going to say that one of the things when I first started digging into kind of researching this episode and reading the blog post, and I see Project Caspian, and it for me immediately evokes either like a Star Trek episode or a John Grisham novel. So
we succeeded. That's great. Yeah,
yes,
that was the goal.
But since we know it's neither of those things in this context, why don't you tell me what Project Caspian is?
Yeah, I can take a swing at that. So Project Caspian is an initiative in Adobe Security to just build a data lake within security data, especially the large sources we have, consolidate it into one place, and then make it broadly available for security researchers and teams so they can do analysis on this data at scale. So one of the kind of limitations we had in the past was just the tech that we had running on the data that Adobe uses, and Adobe's grown a lot. There's been a lot of just growth in this space in the past few years. So there was a real need to expand our technology and our footprint when it came to kind of data lakes in terms of our capability with analysis and kind of statistics on that data that we could give to security teams.
Okay. Are there so if you've got this data lake and it's you're able to kind of draw kind of broad conclusions from the data or whatever, but are there privacy or like cross-contamination concerns with different teams?
Yeah, definitely. That's something that we considered, and we made sure that we followed best practices in terms of isolation of permissions, isolation of data sources, cleaning up sources and making sure that nothing that could be, PII related or anything like that gets fed into the system. So we follow all those practices. When data enters the data lake, there's pretty clear onboarding requirements for each source. There's requirements for teams in terms of what permissions they have. So yes, that's a really important part of kind of the discovery, and also how that went into kind of building Caspian and the data lake environment.
Okay, so I know that so I know that that you guys have also written a couple of research papers. There's Accelerating Security Analytics with a Purpose-Built Security Data Platform. Have to say that title is not quite as catchy as Project Caspian. and anomaly detection in Okta logs using autoencoders. And somehow Project Caspian is kind of combining the elements from this research. So on the output side, like what are the benefits and advantages to Project Caspian for Adobe?
Well, I think that the goal of kind of these two papers is to show that, right? So again, but previously with Project Caspian especially, it was very difficult to do these kind of longitudinal or kind of these larger analysis projects on the data sources we have. So the goal with some of these papers is to show that, hey, with the new tech that we have, here's some of the new insights we can derive, right? Here's some of the new problems in security that are important to tackle that we can now address, right, using this technology. So I would see it as really the purpose of those papers is to show output, right? It's like, here's the results that came out of the tech and the kind of the data lake initiative that we've been pushing for and implementing over the past few years.
Okay. Is the data that's going into this data lake, is it strictly like security related data? Is it like how because let me frame why I'm asking. I've had a number of conversations with people and even on this podcast about the hot term from all of 2023, generative AI. We've talked over and over and over about that generative AI is limited. It's a function of its data sets, and then I've also talked about the idea of I forget the exact term they use, but basically like a collection of experts. Like basically, instead of trying to build one generative AI model that's just the Iron Man Jarvis of AI that just knows everything about everything, that to some extent it makes more sense to build one that knows everything about healthcare, or even narrow it down more, one that knows everything about cancer and one that knows everything about diabetes or whatever. It's just so, because then you can get much more specific about the data and you can derive more specific answers from the data. So what's the data that's going into Project Caspian, and then what are the what are the answers you're able to get from it?
I can speak on the data side. I'll let Jericho talk more about like the LLM and the analysis side, what we get out of it. But as far as what goes in, it's just its main security sources are log sources within Adobe, right? So you can think of things like, I would say network logs are one, but that's also very large. Cloud logs, anything related to cloud and systems, we're all over the place when it comes to cloud. Authentication logs, we're talking like Azure AD, Okta inflow logs, which is part of the kind of the autoencoder work that we'll talk about later. And then, so tons of sources. I mean, I could go over a lot of different nuances of it, but I'd say broadly, it's security sources mainly, but also just internal log data about, hey, how do our hosts behave on the system? How can we capture information about what's going on in the network or on the edge? Some of that has security implementation. Some of it's just
I was
going to
say that you're getting into like the tangentially security stuff, where it's like you might not directly think of it as security, but as you're trying to connect dots, that kind of machine or user behavior analysis becomes important, where it's like the data itself isn't security data, but when I connect it with the security data, it is enlightening. Jericho, do you have any thoughts on?
Yeah, I mean, well, centralizing multiple different data sources from a data science perspective is always good. I mean, you can imagine, the paper you read was on Okta, but there's probably information that we could glean about user behavior across different platforms, not just Okta. You can, for example, if we see in Okta somebody's traveling, right, but in another data source they're not, that's kind of suspicious. You wouldn't really be able to do that unless you were able to easily look at multiple data sources at once as sort of a holistic picture. So I'm hoping that we can, go somewhere with that, being able to get a holistic view of user behavior or whatever else we want to look at in the data.
Yeah, it user behavior analysis is funny because it's been around forever, and to some extent, I always felt like it should be simpler than it is, because I'm like the example you just pointed out. There would be activity coming into a network from Tony Bradley, using my credentials or whatever, but logging in from an IP address in Tel Aviv at 3 a.m. on Saturday. And it's like, okay, well, just no. like I was at work yesterday. I'm not in Tel Aviv, so just don't allow that. That seems pretty simple to me. But I realize there's more nuance than that. And I know that this is not the exact same thing, but when you travel, Visa, MasterCard, your bank, whatever, try to limit fraud. So when they see charges from Madrid, they go, "Hey, Tony doesn't live in Madrid. We should block that." But I am in Madrid. I happen to be vacationing in Madrid, and I know some people will actually call the bank and tell them up front. I never have. I've never done that. But the banks too, I think, should have, they've got some ability to connect the dots. They can, there's enough publicly available information to be able to say, okay, well, Tony bought an airline ticket and Tony's in Madrid. So anyway, that's a huge digress from the topic for me to rant about behavioral analytics.
I was going to say though that but it's applicable here, because the point you're bringing up is hey, this should be an easy problem to solve. And why hasn't there been more work to try to make it, basically make it easier to know if a user changes from their baseline behavior, it should be easy to see that, right? And that was the motivation for us approaching the anomaly detection topic with Okta, because we feel the same way. We feel that fundamentally we should understand if a user changes significantly from their baseline behavior. So you're right on with that. That really is, that to us, that's a very important thing to address, and it's more important than ever, given the fact that the human element, when it comes to security attacks in the past year, that's been the main focal point for attackers going into organizations.
Yeah, well, and I think that two things. Number one, I've recognized over the years that we talk a lot about users in terms of behaviors, in terms of multi-factor authentication, in terms of whatever, but that the human being users are the tip of the iceberg. There's way more machine accounts, service accounts, all this stuff is going on in the background where multi-factor authentication doesn't even come into play, because it's just machine to machine. But you also need to be able to identify those anomalies as well. And then it's just a matter of finding that balance between, I want to identify and block this anomalous traffic as effectively as possible without having false positives that prevent people from getting actual work done. So how do you strike that balance?
Yeah, that seems to be the sort of ongoing theme with this kind of work. Too many false positives makes sort of a human analyst, overwhelms them in terms of having to actually find cases that are legitimate or not. So yeah, I mean, that's what we've kind of done in the paper. We've, used machine learning, chosen thresholds that allow us to sort of optimize for true positives without overwhelming them with too many false positives. But yeah, that's always the challenge right there.
What, if anything, does the user end up seeing when it comes to Project Caspian? Because the examples I'm thinking of are, one, I don't remember the exact name of it, but when I think it was Windows 8, when Microsoft introduced the thing where every time you tried to do something that was even remotely administrative, it had the pop-up where you had to authorize it. Or in the light of European regulations, every single website I visit asks me to accept all cookies. And while both of those things I understand at face value are logical security measures, like it makes sense to say, hey, you're about to do something that could, access core components of this operating system. Are you sure you want to do that? That makes sense. But by the 15th time you see that, people just click yes. Like I say yes to all for like all cookies because I don't have time. I'm not going to go read all of your cookie policies and figure that out. It's like an EULA. It's like I'm not going to read the 75-page EULA before I decide that I want to play this game. I just want to play the game. And so, so a very long way of saying that a lot of our security measures end up creating kind of the opposite behavior, where it becomes a default yes, like it's overwhelming for the user, and I'm like, yeah, just go.
I mean, that's a problem with not just that space. I mean, it's a problem with ticketing. I mean, it's a problem with there's so many things in security where exhaustion of trying to prod people and say, look at this, look at this, look at this, can become itself a blocker to implementing security things. So to your point, though, like the way we do it is we start with domain experts. So that would just be the Okta admins, the people that understand the system more than anyone else. And so we give them the anomalies that we generate from this model. And again, this runs on all just the login data that we get. And then they can evaluate it. They can say, hey, is this worth escalating to the user or not? And I think, what Jericho was saying earlier, our goal was to try to really reduce the false positives. So what the model really gives to the Okta admin is the most unexplainable events. It's like, hey, I've tried my best to analyze these events, categorize them. This one I can't explain at all. So why don't I need a human to intervene to tell me what I'm missing, right? So that's basically what the model's doing. It's handing its most unexplainable events, which is what we want, incidentally. It's the ones that like deviate the most from the baseline.
Well, and that also has been a consistent theme over the past year as I've talked to various companies, both just tech companies and cybersecurity companies, when it comes to AI and generative AI and ML, like all of these things, while there's the sort of public media narrative of Skynet and the AI is coming for all of our jobs, I think it's fairly unanimous amongst the tech industry that no, the generative AI is there to augment and amplify what you're doing. It's not there to replace you. It can't really function without the human. It's a teamwork effort. And so what the AI is doing is just doing the grunt work of being able to sift through an overwhelming amount of data to say, hey, look, here's the 5 things you need to do right now.
Yeah, I mean, that's been my experience in almost every job that I've worked at. The most successful models tend to be assistive. For needle in the haystack problems, it's about clearing away a lot of the hay, so it's easier to find the needle rather than finding the needle itself a lot of times. There's also in preparing the data oftentimes requires massive human intervention for even just annotating and labeling, which is very expensive. And that can lead to exhaustion and error. So yeah, I definitely agree with what you said there.
Well, and I think in cybersecurity, a lot of times, like we always talk about the needle in the haystack, but it's a needle in a needle stack. It's like they're all needles. You're just trying to figure out which of the needles should I care about.
Yeah, definitely.
And that's a good point too, because that's something that if you want to talk about known knowns, unknown knowns, like fog of war stuff, that's a lot of this stuff at the edge in terms of how users interact with our system is we just don't know enough. So the first, honestly, a lot of this first pass as well is also helping us understand our users better, right? It's like, because the more we know, the more we can catch if their credentials are exfiltrated or if some type of event occurs that we need to take action on sooner. Right. So that all feeds into that. It's like, how do we know that the needles we think are there are actually real and they're not just made up? And then also maybe there are new ones that we missed. Right. So it can be kind of a tough balancing act.
Yeah. Well, Jericho, I think this is directed at you, but can you provide a little more like overview or insight into the autoencoder part of this? Like what is the autoencoder doing for us?
Yeah. So an autoencoder is, it is a type of neural network. Like all neural networks, or all machine learning problems, if you wanted to generalize it quite a bit, you essentially have a function that you give it some input and you get some output. And you can control what that function is. So if you wanted something linear or nonlinear, you can control that with what function you choose. And so the input is features. In our case, it's, features from the authentication logs, maybe like location, time of login, day of login, device type, those sorts of things. With a neural network, though, that sort of general framework I gave for machine learning, you can just imagine they're all chained together. You have layers of these processes that are all chained together, which allow you to capture a lot of complex behaviors. Now, on a typical machine learning problem or deep learning problem, we call them supervised problems, where you know the answers associated with your historical data. So when your model spits out an answer, you can just do a comparison. You get an error, which is called a loss, and you can use some math with that loss and go back and adjust parameters inside that model so that when you make another pass, you're maybe closer to the answer. Well, in our case, we don't have labels, right? We have our data, our authentication data. We're looking for anomalies in this data. And so we turn to something called unsupervised learning, and an autoencoder is a popular unsupervised learning method. And the difference between an autoencoder neural network and a regular neural network is that an autoencoder is actually trying to rebuild its own input. So you can kind of imagine, let's say we had an array of 10 numbers that somehow represented our data. It would go into this autoencoder, and the autoencoder in the first layer, it's called an encoding layer, it does a sort of compression of the data. So instead of using 10 numbers, it'll try to represent it as maybe 5 numbers, as an example. And in this, there's some information loss, right? But the information that's going to get lost are rare events, like an anomaly. So then the next, that compressed representation is often called a latent space representation, or the coded layer. The next layer you have is a decoding layer, which attempts to take that compressed representation and rebuild that input. Well, now when it rebuilds that input, since it's lost that information, that rare event's been lost, what it rebuilds is going to look very different than what it started with. And so when we compare those losses, if it is different, they're going to be big. And if it's not different, the losses will be small. And so when we get the alert that, hey, there's a big loss here, as an example, this guy usually logs in San Diego, and now he's logging in, in a completely different country, it's going to alert us. We're going to see that big loss. And so the autoencoder for us is a way to quickly filter out these big differences, so that we can then maybe run some quick post analysis, and then if they survive that, we can just hand them off to some domain experts to say, hey, we need a human to look at this, we've got some weirdness. And the more things that are different, like say it's location, they're using a different device, logging on from a weird time of day, the bigger the loss is going to be, and the more severe critical it is to look at that login.
Okay, so there's a little bit of a scoring model to say, Tony logged in at 10 a.m. instead of 9 a.m. Yeah, we'll make a note of it. Tony logged in at 10 a.m. from Tel Aviv. Okay, that's going to rank higher.
Using a tablet, which he's never used before.
Right. Okay, so all of that makes sense. I realize that these are not necessarily directly parallel, but one of the common things that I see people talk about, and I've experienced myself when it comes to generative AI, specifically with image generation, is like, you tell it to create a human hand and you end up with like 8 fingers. You tell it to create, over the holidays, I was trying to create an image. I wanted to create an image to share on social media for Hanukkah. And it kept creating a menorah with like 14 candles. And no matter how many times I tried to adjust the prompt and say, no, the menorah only has 8. The 8 plus the middle. And I later learned from someone else that actually, and this is very much off topic, but actually menorah is just the Hebrew word for candelabra, and they're all menorahs. That the one we think of is a Hanukkah. It's a specific kind of menorah. But so this is part of a conversation where someone was trying to justify the logic of the AI. They were saying, well, technically the AI is right, and I was like, all right, but still, I did narrow it down and I specified. I said I only want 4 on each side plus the 1 in the middle, and it still just kept doing like these little phantom candles that weren't even connected to anything. They were, it was like the menorah itself was technically true, and yet if you looked at the image, there were still like 14 candles. They were just kind of floating there in space, and all of that to say that these things are not flawless. So my question is, when it comes to Project Caspian, is there a verification step? Is there a feedback loop that says, hey, you gave me this output from Project Caspian, we looked into it, it was wrong?
Yeah. One of the first things we do is that we worked with domain experts to essentially generate anomalies ourselves, just to see as sort of a sanity check. For example, if there's multiple features, say we generate an anomaly where 5 of the features are different, we expect that loss to be very high versus if just one thing were different. And then as this thing is in production and it's detecting anomalies, we pass those off to a domain expert, and they review them and we get feedback. We actually Hayden could probably talk more about this, but we have a Slack channel where we go back and forth and we talk about this, and it allows us to go back and make changes or adjust some of our post analysis rules, to sort of kind of fine tune it. I always describe it as a kind of a pseudo active learning loop. It's pseudo because we have to manually mess with it, but we do kind of have hopes in the future to make it sort of automatic, where an analysis can go and review what the model said, and through his review it automatically can update that whole process without us getting involved.
Okay. Hayden, do you have any thoughts on that process?
Yeah, it's been kind of a really interesting back and forth over the past year in terms of just, again, we had an original set of assumptions when we first kind of approached the model. The domain experts did, and the data and kind of the early modeling. I mean, we've had multiple iterations of this. So, where we started is not where we ended up. But what's been really interesting is just like some of the insights we gained about maybe features that we thought were important that were less. So, for example, location became important to encode properly. So we used something called a geohash to encode all these very high number of logins down to just a more just a larger box or a window that we could assign to a user, right? So that came out of that. The importance of a device, right? If somebody changes their device, like that became much more important. Third-party VPNs, that was something we didn't even think about, that became much more of an issue as we started getting anomalies back. Like, we had a lot of users that are using third-party VPNs more than we thought. That's going to impact, if we can track what's their baseline from that, right? Because if they're just logging in from VPNs, well, that's where do they actually live, right? So a lot of those things have changed kind of how we approach the data, stuff like that. But there have been some really great results. Like the model now, like we've been able to show, like if we've had a security researcher go take their session, log into a VPN somewhere else, our model caught it. We're able to catch if somebody logs in, they're traveling, they change their device, and they log in, we catch that. So the model's catching the behavior we'd like, but like Jericho's saying, it's kind of the active learning loop now is like, okay, how do we get it further refined? Are there still angles we're missing? There's still parts that we need to kind of further work out.
Okay. where are things now and kind of what's next? Is there a Project Caspian 2.0? Like where do you go from here?
Well, impossible travel is one that we're really exploring. We've sort of have a rudimentary version of it. So impossible travel would be maybe, you know, your logins show that you're traveling, but did you get to from location A to B in a reasonable amount of time? Like, you know, you logged in from California and then 15 seconds later you're logging in from Tel Aviv. That's, you know, not possible. So we have sort of a rudimentary way we're looking at that, and then we're using that as a benchmark to see if we want to do something more sophisticated, like potentially looking at using LSTMs to look for time series anomalies to quickly identify those impossible travel scenarios. That's one thing that we're looking at.
Okay.
Are we missing anything
Yeah,
there?
I'd say, yeah, I mean, other domains, I'd bring that up. And like kind of we mentioned earlier, like I think that's something to me that is really important, is not just the window of Okta, but also taking into account, you know, we have a lot of other sources that we can pull from, right? So the more information we can kind of join to this central store of data, the more useful and insights the model can gain, right? So I see also that's to me a big hopeful win from this is, hey, what other sources can we join here to further tell us the story of what might be going on that could be more valuable to give to, you know, domain experts or even the SOC to respond to.
If you think about it, Okta themselves only have their own sort of picture. They don't have access to these other data sources, but we do. And so, yeah, if we can look across data sources and draw, you know, strong conclusions, that would be fantastic.
Yeah, and that's something that I'm seeing more of. I've had different conversations of you know, different vendors trying to, you know, coming to this realization, and some of it kind of goes back to 2022, summer of 2022, when Gartner put out the continuous threat exposure management report, and basically said, hey, look, you know, you've got a firewall, you've got vulnerability management, you've got endpoint protection, you have all of these things, and they're all great at what they do, but they're only great at what they do. You know, it's like you can have a great hammer and a great drill and a great saw and everything, but like you need all of them to build a house or whatever. Like you can't just have a great saw. And you know, so there's this sort of, I think, industry-wide recognition and effort to say there needs to be this like holistic abstraction layer that says, hey, let's look at all of these tools and try to connect the dots. I was going to say that, yeah, it's a quick side anecdote, but when you were talking about impossible travel, it reminded me, and for all I know, this was probably just a fear tactic rumor planted by the Ohio State Police. But I grew up in Detroit, and when I got my driver's license, we would go to Cedar Point all the time. Like it's right there. You know, this is like a 3-hour drive. You pop down to Toledo, Ohio Turnpike, straight across to Sandusky. The Turnpike. You get your ticket when you enter the turnpike, and it's time-stamped. And then you pay the toll when you exit the turnpike, and it's time-stamped. And so the rumor was, well, you can't speed because they know the 2 timestamps and they know the speed limit. So if you get to point B faster than you could have legally by driving, then you're going to get a ticket. And so like we would stop and like of course we didn't slow down, we would still speed. But we would just make sure we stopped and like had lunch or something to like draw out the time to make sure that we didn't cross the impossible travel time threshold. But again, you know, I have no idea whether that was actually true, if they would issue speeding tickets based on that, or if that was just a rumor to scare teens.
Hey, it's probably worked. It sounded like it did work, but you found a way around it.
Well, I was gonna say, did it? Yeah, we'd still go 90 in a 55. We would just stop and have lunch. Yeah.
Well, maybe that's what the actual motivation was. The businesses were in on it to get you to stop and have lunch.
It wasn't the Ohio State Police. It was McDonald's. They were the ones behind the rumor. All right. Well, you know, so you know, I guess I don't have any other specific questions, but I guess I will kind of open it up to, was there something that you wanted to touch on that I didn't ask about?
I think from my end, I think I'm good.
Yeah, I mean, I have a few thoughts. It's just the kind of elaborating on where do we go from here. So just emphasizing like again, like the risk over the past year that we've seen is that the human element is the most important factor that's being targeted by all these new ransomware attacks. Like if you think of like the MGM hack, I think Cloudflare got hacked as a result of the Okta hack that happened last year, right? So you've got like all these major things. All the main issue was the human element, and so the thing that I just want to call out is that's really the objective of kind of this initiative is like, hey, how can we better understand the human element in all of this? And how, more importantly, how can we protect our users from being taken advantage of or having their credentials exploited in ways that they may not be able to protect themselves against? No matter what we can do or no matter what they do, people are going to make mistakes. Things are going to happen. And so we need to have processes in place that can catch and assess these risks early on. And so that's the goal of this model. I think that we've made good strides, and the hope is to further expand it, to make it something that allows us to, again, protect our users and protect Adobe generally from these types of threats.
One thing that just occurred to me that I think you bring up a good point is, I mentioned earlier that from an identity perspective, users are the tip of the iceberg. There's exponentially more non-human identities out there. But from a risk perspective, that filter changes. The humans are still the Achilles heel in that equation, because your machine and service accounts aren't clicking on links and opening attachments and surrendering their credentials to random messages. So it is the humans still that is the weak point in that equation.
Well, to take the example of Cloudflare, I mean, what happened there was that, Okta got popped and all these admins' credentials got exposed. And so what these ransomware attackers can do is they can focus in on one engineer or something like that for their ransomware attack or campaign. And so if you're being targeted by an entire group and they're going after you and they try to learn about you, I mean, how are you going to protect yourself reasonably against that? Not easily, right? So
right.
The goal is like, okay, like, can we help with that? If we know something about that user, we can at least protect. We can do a double check and be like, hey, if they traveled somewhere they shouldn't have, and they used a device or something else, let's check. Let's do a sanity check. Make sure it's reasonable. So that's kind of the goal too. It's like I think we have an opportunity to protect our employees further and protect Adobe's interests in this space.
Yeah. All right. Well, thank you both for joining me and taking the time. Interesting work.
Thanks for having us.
Thank you.
I appreciate you investing your time to listen to the podcast, but I also invite you to engage on social media. Please go like our Facebook page and follow @TechSpective on Twitter and Instagram. You can feel free to let me know what you like, let me know what you don't like, let me know if you love it, let me know if it sucks, and let me know what products you'd like to see reviewed or what questions you'd like to see answered in future posts.